Today we discuss your normal distribution. So for the continuous year data, you can refer your this normal distribution tables, and your this normal distribution. We say if x is a normally distributed with mean mu and variance sigma square, then it can be represented by n bracket mu comma sigma square. And the probability density function for this normal distribution is your fx, and which can be represented by 1 by sigma under root 2 pi into e raised to power minus 1 by 2 into x minus mu divided by sigma whole square. And here this x lies between minus infinity to infinity. So data is normally distributed. If we say the graph is your like bell shaped, then we say data is normally distributed. And this here you have x is your minus x, and here x is your plus minus infinity to plus infinity, right? So the standard normal distribution. What is your now standard normal distribution? So if your normal the function probability density function, if we take the integration from your a to b, this is called your probability of your x when your x lies between a to b range, right? So this is your normal, right? Now we want to if you see graphically this one, so this graph is like this, that is your bell shape, and your x running from a to b. So this range is called your probability of your x from a to b, or for your range a to b. This complete area is your 100% we consider, right? So in case of your standard form, in case of your standard form, your we can just shift your this axis, y-axis, from your this horizon to your here. So we shift your this axis here, that is fx, or that is y-axis, into your this z, and that function we rename this as your f of z. And what we do here we use the substitution, that is z is equal to x minus mu, and mu is your mean of your for your x variables, and sigma is your standard deviation, right? And this is your x values. So for shifting this into your this z variables, so we can use this as a formula, right? So, and if you compare these two, we may say this z is your can be written as your z minus 0 divided by 1. So that means there is a relation between your this x and z variable is that your here your if mu is mean, so in case of z variable your 0 is mean, and if in x sigma is your standard deviation, so here 1 is your standard deviation. So we convert your normal distribution into a new distribution where your mean is your 0 and standard deviation is your 1. So this is called your, and variable is your z, right? So this is called your now, you may write 1 or you may write 1 square, because standard deviation is 1, and we write here this, right? So this is called the standard form of your normal distribution. The difference between your standard form is that here we shift their this y-axis at your point where x is equal to mean, or here a point where x is equal to mean, the sigma, sorry, z is equal to your 0. So in old graph, your here x is your 0, but the point where x is 0 is your called your new direction of your y-axis, where z is equal to your 0. So if you see here, what is the benefit of this? Once you break this into or shift this axis in point where z is 0, or you say when x is equal to mu, that means we divide this normal distribution into a two equal part, and that means your both side your probabilities is your 50%, right? So 50% on your left hand side and 50% on your right hand side, and that 50% means your probability is zero point 0.5. So right side probability is your zero point 0.5 and left side probability is your also zero point 0.5. As we know that your total probability of this system is always 1. So once you convert your normal distribution into a standard normal distribution, your all graphs are with your divide into a two equal parts, right? So one is your right side, another is your left side, and both side your as this is symmetric distribution, both side your values are same. So I'm just mean that if we say z here and we take minus z this side, that means your area covered by minus z to 0 is same as area cover 0 to z. So as both side are symmetry with each other, right? So once you convert your distribution into a standard distribution, standard normal distribution, so we have a one table that is your called normal distribution with your one tail. So one tail means we convert this into a this into where mu is equal to 0 for the standard distribution, and that tail means we all table calculation are given according to the right side of this, one side of this. That tail means your one side of this, that is means you are from 0 to z. So that means your this table is your given for your this, the probability given here is from 0 to variable capital Z as used as variable, and small z is your point. So this table is called your normal distribution tables. So suppose if you like to find out value at your 1.4, so thus you just needed to see the 1.4 here. So at 0, you get this is your result, that is probability from 0 to 1.4, right? So all calculation given in this table is start from your 0 to z, right? Keep in mind all values are your starts from your, that is your 4192. So all values start from your 0. This is important here. So here if we have some example. So if you see here in this first part, we are interested to find the probability that the value of standard normal random variables be 0 to your 1.74. So that means we are interested to find the probability from 0 to 1.74. So this table is also given from 0 to. So we just needed to check your 1.7, and then for your 4 we can check this one. So we see column wise this intersecting point of this row and column is your 0.4591. So this is your, this should be your result. So 0.4591. So hope so it's clear to you. So in second point, please try to understand all these examples. These are important for main questions of this. So this say that your probability is your less than negative value of your 1.47. So when you say your left side of your 4.7, no end is given on the left hand side. That means this move from your minus infinity to your minus 1.47. So we know that your the normal distribution is a symmetrical distribution. So if it is symmetrical distribution, suppose this point is your minus 1.47. So the minus infinity to minus 4.7 means your this area, right? So if we find some point here right side that is also at your plus 1.47, so this means your the area is your this one, that is 1.47 to your infinity is same as your this negative side area, because this is a symmetric curve. So we may say, we may write this probability is can be written as your 1.47 greater than z and greater than infinity, right? So but problem is here this is your 1.47 to your infinity. So but our table should be done from this point. So we may say, we may consider your 0 to infinity, and then we subtract this 0 to your 1.47, that give you this part. So I'm saying here we can require all calculations should be calculated from 0. So that means we can start from your 0 to always. So we can use your 0 to infinity, that is all right side, and we know that your half part probability is 0.5. So this probability is your 0.5, we know that. And if we subtract from this inner part, that is 0 to 1.47, so that is again from your 0 to 1.47. So this probability 0 to infinity, we know that is your 0.5, and this 0 to 1.47 we can check from the table. So if you see 1.4 is this one, and corresponding 7 from this is your 0.4292. So we will write here 0.4292. If we take the difference of this, that give you a 0.0808. So which is your required probability, right? So we may see another example. Between 1.3 and zero point 0.2. So when you say 1.322, that means in this graph, so we may consider same graph, same, right? So it is symmetric. When you say your value is your between your 1.3 to 2, so suppose this one. So this is your area, which is required area. So we all calculations should be start from your 0. So we may say 0 to 2, and then we subtract 0 to 1.3 from that, then we get your this one. So here we do your probability from 0 to 2, and then minus probability from 0 to 1.3. So we can see the table at 2, because complete table is given from 0 to something, right? So we can see this 0 to 2, that is your at 2 it is your something 0.4772. So it is 0.4772, and at 1.3 it is something 0.4032. So 0.4032. If you subtract this, you get your probability from 1.3 to 2. So similarly, we can understand one more example from minus 1 to 2. See again, we go to the value given is from here -1, -1 to 2. So that means your area is on both sides, negative side of this and also positive side of this. So all calculations should be start from your 0. So -1 to 0, we know that as this is a symmetric curve, so -1 to 0 should be same as 0 to 1. So for this, we needed to add two probability. One is your -1 to 0 plus 0 to 2. So we can add this into two part, and we write this into two part, that is probability from -1 to 0 plus probability 0 to 2. And for this here -1 to 0, we know that curve is symmetric. So the -1 to 0 probability is same as your 0 to 1. So these two are same. So we can write this -1 to 0 as your 0 to 1. So we have the table for 0 to 1 and 0 to 2 also. So we just needed to check at 0 to 1, it is 0.3413, and here it is 0.4772 at your 2. We just needed to put these two value, and because of both sides we can add these areas, right? So here in this example we discuss from 0 to a, minus infinity to a, and a to b, and negative minus a to plus b. So all these four cases we possible chances we discuss here. One more thing is possible. If we saw the value is here 1.645. So if you see here table, this table is up to 2 decimal here only, right? So if we have the 3 decimal, what we do? So in that case, we can break this into a two part, that is 1.64 from 0 base, from 0 to 1.64, and also from 0 to 1.65. And as this point is lies between these two, so we can take the average of these two. So we just break this probability into two probability, that is your probability 0 to 1.64 to 0 to 1.65, and we see, just check the table, at is 1.6, and at 4 it is your this value, and at 5 it is this value. We just take the average of these two, right? So just take the half of these two, we get your required probability, right? So another thing which can be possible here, if probability is given, like if we say that in a coming example, if you see here, it is 0 to less than z, and some small value, that's suppose z or z1 we may say, right? So the probability is given. Suppose if probability is given, we needed to calculate your z1. So at what point this probability is lies like this. Find the z of the standard normal distribution or variable such that the probability that random variable will have a value 0 to z is your 0.4. That means probability is your 0.4. So we know that here always we consider from 0 to z. So 0 to z is given with probability 0.4. So we just check the answers in table. These values we can needed to check which is nearest to your 0.4. So if you see a table carefully, you can see this value is 0.3997, and this is your 0.4015. This is more closer to your 0.4. So we prefer this one, right? And if you see here, this is at 1.2, and second digit after decimal is your 8. So result is your 1.8. So this value is lies at, given your z is 1.28. So that means with the if probability is given, we are also able to calculate here at what point this probability is lies. Right. So like one more example here, if you see, find 0.99 probability intervals. So intervals we needed to find, that means two value of z we needed to find here. Symmetric about 0, so this is symmetric, that means it is obvious normal distribution for a standard normal distribution variables, right? So if you know that in case of your normal distribution, your graph is here like this. So it says here this area where this probability, this complete area where probability is your 0.99. So that you may assume that this point is your minus z1 and this is your z1. So as both side probability is same, we may calculate this like here. This is your from minus this is your from, you say Mr. P from your minus z1 to your 0 less than z1, right? So this we needed to calculate, but instead of this we may say this is same on both sides, so we may say 2 multiply your probability from 0 to sorry, we may write here this as capital Z, right? That is more from minus z1 to your z1, and we can write this as your from 0 to your z1. So as you see here, your both sides are equal, so we can consider from your 0 to z1 and we just multiply this by 2, and this probability given to us is your point, this probability is given to us is your equal to 0.99. So that's mean your, if we calculate for your 0 to z1, which is equal to half of 0.99, that half of 0.98 is your 495, right? So now you needed to check in a table only that where we get your 0.495, that value is called your z1, right? So just see the table. So if you see table 0.495, so if you see this is your something, these two are very closer to your 0.495, right? This is also at a difference of 0.0001, right? So you can choose any of these value or you can take the average of these two, it's your choice. So this value is at your 2.5 and corresponding column is at 7 and also 8. So we may say 2.57 or you may say 2.78, or if you can take the average of these two. So if you see here, the z1 is your, from the table, z1 is two value. One is your 2.75, another is your 2.57, and another is 2.5. So we may take the average of these two for final value, or you may choose any of them that are same thing. So average of these two is your 2.57. This is value of z, and our interval is lies between your minus z to z. If you see our starting your probability 0.99 is lies between an interval that is from minus z to plus z, as we already see, right? So one more thing, as this is your 0.9 and very large value, so if this value is more than 0.5, that means half of. If value is probability is more than 0.5, then we go for the negative side. If it is less than 0.5, then we study only right side of this graph, right? Normal distribution. So here the table was your minus Z1 to Z1. So that is here your this minus 2.5752 your plus 2.575. So here we discuss all kind of possible chances where how we can look here on table. So what kinds of possible tables are possible we can discuss here, right? So in the next lecture we can discuss main problems on this, right? So one more thing I just like to add in 1 minute. So if your this probability is your less than suppose it is zero point 0.3, right? So when it is less than and we want interested to find out the interval, so it is always start from your 0, right? So 0 to 3 because this is from this side also. If this value is more than zero point 0.5, so then we go for the negative side also, right? That we already chosen here minus z1 to z1 because both are symmetric, right? So anyhow, so I'm stopping here. Thank you for listening. In coming lecture we can discuss few more good example based on your this normal distribution.